electric current. Electric current is a very common phenomenon which we see everywhere. The reason that a bulb glows, or the reason that, say, an iron box becomes heat, or the reason that a refrigerator runs. Now all this is because of electric current. So to define this, electric current can be defined as it is flow of charges. So flow of charges is defined as electric current. Now keep in mind that in an atom there are basically three kinds of charges called as an electron, proton and a neutron. So these three together constitute electric current. Now if we look at model of an atom, then what we see is if this is like an atom, then at the center of the atom there is the nucleus present. The nucleus contains electrons. The nucleus contains not electrons. Electrons actually move around the nucleus in some orbits. The nucleus contains protons and neutrons. So these two together constitutes the nucleus. Now whenever we say charge is flowing, it basically means electrons are flowing, because electron is at the outer side of the atom while the nucleus is inside the atom. But earlier, when current was discovered, people didn't know what the atomic model was. People knew that charges are from two kinds. In fact, only in 1932 neutron was discovered. So until then, people thought that charge means it's electron and proton only. People that time called as positive charge and negative charge. So people thought that current may be because of flow of positive charge. That's the reason that many books define current as flow of charges, but in practicality or physically, what flows is the electrons only flow. But first we'll define in terms of charge only, but keep in mind that physically what flows is electrons only flow. Now to define more technically, we can say electric current. It is called as electric current because the idea of current is a common term. Current can mean flow of charges, current can mean flow of water, or current can mean flow of some other fluid also. So wherever something is flowing, it's called as current. So to differentiate these kind of different currents, we call the current as electric current. But in physics class, whenever the word current is used, it implies it is electric current only. So we'll define this now. Electric current is defined as the charge flowing normally through any given area in space in 1 second. Now this is given very long here, but ideally what it means is that if we have a conductor, the conductor is highly enlarged here. Think of a small wire, a very thin wire. It's been enlarged here. So if some charge Q flows in this wire, then current is given by, it is the charge flowing by time taken, or it is defined as rate of flow of charge. So mathematically, current is given by charge by time, or rate of flow of charge. Now many metals will conduct current. For example, think of materials like conductors, or think of something like ionic solution, or think of something like semiconductor. So there are many more devices. Let us stick only with these three basic devices. In all the three cases, current will flow, but the cause is different. In case of conductors, it is the free electrons. In case of ionic solution, it is ions. And in case of semiconductor, it's called as electrons and then holes. We will see what these are when we take upon semiconductors. But for now, remember, the cause or the motion could be something. It's free electrons or ions. Ions also could mean positive and negative ions also. Or it could be because of electrons and holes. So in case of conductors, it is because of the free electrons. That is called as current. As seen here, example is given here, and we find how current is flowing. Now for current to flow, what is very important is we need a potential difference, because without a potential difference, current will not flow. So a potential difference is essential to establish a current. Just think of heat. If you have a conductor and if you have 2 points, we'll call as point A and then point B. Let the temperatures at point A be T1 and point B T2. If we assume that T1 is more than T2, then heat flows from point A to point B. So for heat to flow, we need a difference in temperature. So difference in temperature is required for heat to flow. The same way, for current to flow, we need a potential difference, and this potential difference can be established by using a normal battery. So by having a battery, we get a difference in potential, but keep in mind that the battery itself will not provide charges. The battery, whatever is supplied or connected, the battery is like a water motor. A water motor will not give us water. Same way, battery will not give us current. It only provides a pathway for charges to move. So because of this battery, charge will flow and we get a current. As seen earlier, there are many instances of current around us. In fact, almost everything around us works on current only. Current is so important for everyday life. It is now defined as to what is a steady current and then an unsteady current. As the name tells us, steady means something which is stable. To define it, we can say if the rate of flow of charges does not vary with time, then it is called as steady current. Now we can write current in many ways. Some books will write current as charge by time. Some books will write as delta Q by delta T. This is called as average current. So this is called as average current. It is given by delta Q by delta T. And something we write as instantaneous current, and this is given by dq by dt. Now these two are not exactly same. There's small difference between them. But then for class 11-12, it is not required to go into such depth to understand what is the difference between these two. Just remember that any parameter which is charged by time will give us current. But ideally or technically, these three are not exactly same. There are small difference between them. But for sake of understanding, just think that any parameter of the form charged by time is called as current. Now if this parameter remains constant, then it is called as steady current. For example, if a charge of 2 coulomb flows in every 1 second, then for every 1 second, if charge 2 coulomb flows, then it is called as steady current. But if it varies, for example, the charge of 2 coulomb flows in first second, and the next second charge of 1 coulomb flows, and suddenly the next second charge of 3 coulomb flows, If that rate is not constant, it's called as variable current. So current could be steady current or variable current. Now let us look at its units and dimension. Now current is one of the fundamental physical quantity. There are 7 fundamental physical quantity, out of which current also is one. And for current, the SI unit is ampere. Keep in mind that whenever you write a unit which bears the name of a scientist, then that should be written in small letter only, like this. Writing it as capital A, if you start with capital A, this is not correct, it is wrong. This is unacceptable. One example could be of Newton. So this is correct, or we can write just its symbol, which is capital A or capital N. Writing capital N into Newton is wrong when this represents a physical unit. While writing the scientist name, we should write in capital letter only. But when that name represents a physical quantity, in that case it can't be represented or written with a capital letter. And its dimension formula is just A. And also it is a fundamental unit, because since current is a fundamental physical quantity, its unit will become a fundamental unit. Now let's define 1 ampere. We saw that mathematically current is given by charge by time. Now to define 1 ampere, what we can do is we can make charge as 1 coulomb and time as 1 second. So if you have a conductor, and then in the conductor, if a charge of 1 coulomb enters or leaves, for example, if charge of 1 coulomb leaves in 1 second, then that current is called as 1 ampere. So you can say that 1 ampere is said to be the current flowing through an area, because current will cross a given area here, it will have cross section, it will cross a given area. So 1 ampere is said to be the current flowing through an area if a charge of 1 coulomb flows across it in 1 second. That is called as 1 ampere. Basically, we are making charge as 1 coulomb and time as 1 second. Then what you get is 1 ampere.